All right. So welcome to our advanced Python workshop, day 2. So we're just going to continue where we left off yesterday. We have 2 more topics to cover today, so the class might be a little bit faster, it might end quicker. But the first thing I'm going to start off with is by reviewing our challenge problem. I don't know if any of you guys attempted it, but this is the code that you would need for the challenge problem. If you remember, it was to count the amount of vowels in a phrase that you typed in. I can just paste this in the chat if any of you guys want to show me like anything you attempted or anything you did. You can feel free to share your screen or let me know. If nobody really attempted it, that's fine. We can just move on to our next topic. So just speak up now if you did anything with it. If not, we'll just move on. Okay. Looks like we'll just go to our next topic. So our next topic is going to be concurrent programming. Now, this is one of the harder ones that we'll be covering through our course. Actually, concurrent programming and meta classes in particular, these two are a bit harder than the ones we did yesterday. In terms of length of code, they're around the same, but the concept is a little bit harder to understand. So I'm just going to do my best to explain to you guys. If you have any questions, feel free to ask. So concurrent programming, as it says in the name, is basically just executing multiple tasks at the same time or simultaneously. And then how this works is Python divides the work into smaller subunits, and then it executes them independently, but also at the same time. So by using these techniques, such as threading, multiprocessing, or asynchronous programming, concurrent programming enables efficient parallel execution. Parallel execution just means at the same time. So all of them, whatever is happening is running at the same time. You don't have to wait for a task to finish before starting a new one. And concurrent programming enables efficient execution because you don't have to wait. So because everything is happening at the same time, it happens quicker, which leads to improved performance and resource utilization. So what we're actually going to be using today is called threading. You guys might have heard of this before. This relates a lot to computers. Computers use threading to be able to execute programs and different softwares a lot more quickly. So in this example, we're going to demonstrate concurrent programming in Python by using threads. And we'll create multiple threads at the same time that perform tasks simultaneously. And then this allows for, over here, parallel execution. And this just improves performance and overall efficiency of the program. Okay. I'm just going to reshare only to the editor. Give me 1 second. Just this. All right. Okay. Can you guys see the editor screen? Oh, all right. Okay. So what we're going to start off by doing is just importing the threading module. So threading is not by default incorporated in Python. It's a module that you need to import so that you can get the functionality. So the first thing you're going to do is just to import threading. All right. That's going to be our first line of code. And then we're going to be writing our function. And this function is basically going to be executing each thread concurrently. And to do this, we're just going to incorporate a for loop. And in this example, it's just going to print some text messages. I don't want to do anything too complicated since threading itself is kind of a difficult topic. But we're just going to write our for loop to define what the threads are going to do. So we're going to do define task. Task is just going to be representing what we want our threads to do. We can do, and then in parentheses, name, And on the outside, have a colon. Now this is where our for loop comes in. Remember, I explained this yesterday. So for loops allow you to set a limit so that you can specify how many iterations of times you want the task to be done. In this case, we'll just do 5, for example. So I'll do for I in range. So I just stands for integer. And then we set our limit in the parentheses, 5. So we'll have our limit as 5. And then after that, we're going to do print. Did someone have a question? Okay. And then executing, threading, or executing task, not threading. Task, and then in curly brackets, name. So then we're matching this parameter over here, executing threading task name, colon, and then we do our so I, and then close the parentheses. I'll just give you a minute to do that. All right. Just make sure all of this is within quotation marks. I just had trouble over here for some reason. The last quotation wasn't appearing on the end, so I just had to print a set and then recopy it into that. But just make sure it looks like this. Okay, and then we're going to be creating our threads. So this is just representing the tasks that are going to be executed. We actually haven't created our threads or the list to encompass our threads yet. So I just want to make sure, is everyone done with this part so far? Just give me like a thumbs up. All right. Okay, so now what we're going to be doing is creating the list needed for the threads. So remember, we used lists yesterday. Lists just encompass data. So, and lists are represented by an open and closed bracket. So we're just going to do threads, and then is equal to, and then this open bracket and closed bracket. So this is going to be our empty list that we created to store the thread objects. So next we're going to be creating our thread objects. We're also going to be using a for loop to this. So we create multiple threads and assign the task function as the target to be executed by the thread. So this task function that we've created here, this is what's going to be executed by the threads that we're creating that will be encompassed in this list. So we're going to say for I in range. So again, same thing that we did up here. We're just going to be setting our limit. All right. So for I in range, we're going to keep it 3. It's not going to go past 3. And we're going to say T is equal to threading. So then this is where we needed to import threading, right? So T is equal to threading dot in capital T thread, right? Thread, and then parentheses, target, it equals task. And then we pass an argument. So args is equal to, and then you want open parentheses, you want quotation marks, thread, and then thread equals, and then curly bracket 1. Close curly bracket, and then you want a comma on the outside of the parentheses. And then, yeah. Let me just put F on the outside of thread. And then this should be an I, not a 1. All right. Let me just make sure I did it properly so that okay. Yeah, so this is what your 9th line should look like. And also make sure this equal sign is actually a dash. So this line has a lot of small things that you need to make sure of, such as like make sure the equal sign, or make sure the dash is a dash on equal sign, make sure this is an I, make sure to put the comma. Once everyone is done with this, let me know. And then I'll also just explain what this line does. Um, just let me know when you're done with this line. All right, so can you just give me a thumbs up if you have this so far? Oh, yeah, I can give you the website link. I just wasn't sure. Okay. Wait. Um, okay. Yeah, in case you guys needed the editor again, this is what we're using. Okay, so is anyone ready to move on, or do you guys still need some time? All right, Nivon looks ready. Ishan. All right. It looks like most of you are good. The ones who aren't, you can just continue coding as I just move on, and then I'll give you some more time at the end. So basically what we did here is first we create a loop, and then we create multiple threads, right? So we have our threads over here. And then basically what's happening is that you assign task you assign task as the function to be executed by each thread. So that's what's happening here. So target task. Over here, this first part, threading.thread, this is just accessing the threading module to be able to get the functionality. And then this args parameter over here, what's happening is that you're passing a unique name to each thread using this args parameter. And this is going to be used by this task function over here to be able to differentiate them and use them for identification. Okay, I'm going to move on. So after we've done that line, we have to, our next line is going to be threads dot append. Remember, append just means adding on. So each thread is added to the list, to the basically the threads list that we've created here. So basically, we access this list over here, threads, we append it with the threads that we've created. All right. So you do threads.append and then parentheses t, right? And then we're going to say t.start. And basically what's happening here is it's just started using the start method. Like it says in the name, that the start method just starts the threads. All right. So just to recap, first we access the threading module to get threading functionality. Then we access this task over here, the function that we've defined. The args parameter is used for identification. So it basically passes a unique name to each thread. Once all these threads are created, we access the threads list and we add on the threads that we created. So using the append, and then we call them t, and then we'll do t.start. So that's just starting the threads. All right. Next, we're going to be waiting for the threads to complete. So during that period, we're going to create another for loop. So we're going to do for t in threads. Right. Let me actually just put a space here. Do t.join. And then open close parentheses. So basically what's happening here, the threads are started, and after that you iterate over the threads. So whatever's stored in this list, and then you call the join method. And basically what this does is it waits for them to complete before their execution. So it's just going to wait for the threads to complete whatever they're doing. That's what the join method does. So this is essentially when you're waiting for the threads to be completed. All right. And then our last is just going to be to print. And then open, close parentheses. Over here, all threads completed. So this is just basically saying, we're just printing a statement at the end of the entire program saying all the threads have been completed. Okay. I know that was kind of a lot. Does anyone need like another explanation of how all of this works? Or does anyone need more time coding it? I'm just going to go ahead and run it just to see if it's working. All right. Seems like I have an error. Oh, okay. Just make sure you have a colon here and then tap this. Okay. As you can see, my program over here is working. Executed thread, right? All the way here. So it's 0, 1, 2, 3, 4. So we have, the reason it does 0, 1, 2, 3, 4 is it's printing the first 5 integers of the numerical sequence. So that's why it does 0, 1, 2, 3, 4, because those are the first 5 integers. Then it does this 3 times because we wanted it to be, that's what we defined over here. Right, so it does 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and then 0, 1, 2, 3, 4. After all of that, it prints all threads are complete. Does anyone have any issues with their code? Need time, need an explanation? I'll just give you guys until 1:30-ish. Okay, Yvonne, looks like you're good. If I see everyone is good earlier, then I'll hand it over to Devansh. But again, feel free to ask any questions. And yeah. Oh shoot, Satvik, I didn't mean to message that to you. Okay, so if anyone has any questions, comments, needs an explanation, feel free to ask. Again, we'll just be waiting till around 1:30, and then I'll hand it over to Devansh for the second part. Okay, since it looks like all of you guys are fine, I'm gonna go ahead and let Devansh screen share for our next part. Make sure if you wanna just save your program, you click this save button over here on the editor. And I'll just call it threads. Save it to wherever you want it to be saved. Also, we'll be posting another Zoom link because this meeting will be ending in 10 minutes. So just join that when the meeting ends. All right, I'll hand it over to Devansh.
Okay. I'm gonna share my screen. Okay. So we're gonna be talking about our next topic, which is meta classes. So I'll give like a little quick briefing about what meta classes exactly are. So you might have heard of normal classes in Python, right? Like a big parent class, but now meta classes is like a subdivision of that. So meta classes in Python are a way to define the behavior of classes. they're like the classes of classes. So you have your parent class that you define in the beginning, and meta classes are like a small subdivision of that, which like they can describe like characteristics, attributes of a class. And they provide a powerful mechanism for advanced customization and meta programming, which is basically what I said before, how they provide attributes, and they enable you to control the behavior and structure of classes in a concise and flexible manner. So in this next example that we're going to be creating, we're gonna use meta classes in Python that logs whenever an attribute is accessed in a class. So we'll get into that, what exactly I mean by that, when we start coding. So this is what we're gonna be coding. So go ahead and save whatever Arnav taught you before. Remember you do it from here. And once you have a blank canvas, I'm gonna start. Okay, so the first thing we're gonna first define a meta class. So we're going to do class logging meta and then type. So type is subclassing. It's the subclassing type of logging meta. Next, we're going to define get at attr, which stands short for attribute, and class comma name. These are the parameters. So class, comma name, these are the parameters that we're building into the subclass, the meta class. Okay, and next I'll explain like more in depth after we finish this one chunk. Now we're gonna do print, and here we're gonna incorporate a f string. So we're gonna put f and then in your quotation marks, access attribute, colon, and then in curly brackets, name. Okay, and one more line, we want to return super parentheses dot get attribute and then name. Okay, so get this done and I'm gonna explain exactly what this is doing. Okay, so basically what we're doing with this is there's one key detail that we're overriding this entire part. So it's not actually going to be shown in our code because we're basically canceling this command and we're using a different one that we're going to code later on, and that's going to be incorporated mostly. So this get attribute is actually going to be overridden by these parameters, and it's not actually going to be used when we code the next part. That's going to be what's going to be shown. Okay, so just give a thumbs up so I know that I can move on. Okay, I'll give you like a minute. So in our overridden get attribute, we print a log message with the name of the access attribute. So over here, that's what this is. Okay, just give a thumbs up once you're done with this part. Okay, I'm gonna move on. So now we're gonna define another class. So once again, we use class, and we're just gonna call this my class. And in this, we want to set a meta class to the logging meta. So we're gonna set this equal to, so we use meta class equal to logging meta. And this next part that we're gonna code is what's actually gonna be showed in your module when you run it, when you run the program. And we're gonna set colon, so this is exactly, we're defining what this my class is actually gonna do. So we're gonna define a variable, which is init. And here we're gonna put self. And in this, we want to put a value to self. So you can put any number you want. Self dot value. And this value, I'm just gonna put it to 42 for now. So equals 42. Just give a thumbs up when you're caught up to this part. So this is an example class, which we called my class, and it's to specify logging meta, the meta class, and we're setting that equal to, so logging meta, we're setting that equal to meta class. Okay, so we're gonna define another variable here. So define double value. So what we're gonna do here, we're gonna put self again. So we put the value of self as 42. We're gonna put this back, and here what we want to do is we want to double this value. So we want the meta class to have a double value of self. So we want the program to return self dot value. So first we have it at 42. Now we want to return it after that, after it prints that out, we want it to return it like times 2. So it will print out 84. So we just do that by doing an asterisk, which is multiplication, which is a multiplication sign in Python, and 2. So now it's gonna, after it returns the value of self, it's gonna return another value, which is saying to duplicate that and multiply by 2.
The meeting will be ending in 1 minute, so just look out for the new link that's gonna be posted.
Okay, so since it's gonna end in like a minute, I'll just keep this up. We'll continue after the new meeting is created. So you can just catch up if you haven't finished.